All right, in this video, I am going to show you how to calculate the Laplace of e to the at. That's my end example. We're going to start with e to the t here. So, if I want to do the Laplace of e to the t, well, we go to our formula that we've worked out, or that we know, for what the Laplace transform is. The Laplace of a function is the integral from 0 to infinity of that function times e to the negative st dt. This is an S, not a 5, and I apologize. Anytime you see a thing that looks like a 5 in this video, it's an S. So, it's the integral from 0 to infinity, I'm trying to do this, of e to the t times e to the negative st dt. Well, what I can do is, when I have multiplication here on two exponents like this, or exponential functions, I can put them in the same base. And when I do that, I get that base, and then I get the two pieces added. So I get t minus st. We've done that a whole lot, so you should be pretty comfortable with that. So this thing converts over to the integral from 0 to infinity of e to the t minus st dt. From there, what I'm going to do is, notice both of these have a t in them. I'm going to factor that t out. So it's going to become the integral from 0 to infinity of e to the parentheses 1 minus s close times t dt. Well, that's a really quick integral to do, and it's very, very similar to this one right here. Integral of e to the 10t, well, that just becomes 1 over 10 times the integral to the same thing. So, up here, this piece right here acts like the 10. So, I'm going to take this thing, and I'm going to divide by it right here, 1 over 1 minus s times e to that thing with the t, evaluated from t equals 0 to t equals infinity. So, from here, I got to evaluate t equals infinity into this thing right here and t equals 0. The t equals infinity is going to go to 0. I can explain that pretty quickly. So, I get e to the 1 minus s times an infinity. This thing will become an exponential decay in a certain circumstance. What we would need is this right here, this parentheses, to be to be smaller than 0, to be negative, right? Notice, if s is greater than 1, then I get 1 minus something bigger than 1. What's that give me? A negative number. So, if s is bigger than 1, then what we get is exponential decay up here. So, when I plug in that infinity to this thing, the whole thing goes to 0, because that's what happens with exponential decay. So that becomes a restriction for us here, for this to be an integral that converges. From there, I need to subtract t equals 0 plugged into this right here. So I get 1 over 1 minus s, because, well, that comes from plugging in t equals 0 here, which gives me e to the 0, because that all multiplies out to 0, times this thing. And notice that thing is the same as this right here. Then the last step is to take this negative and apply it into the denominator to make it look better, which gives me, instead of 1 over 1 minus s, it gives me 1 over s minus 1. And you always want to carry that restriction that s is greater than 1, although that's not really going to matter for us all that much. So, next, what we're going to do is calculate the Laplace of e to the 7t. This is very similar to calculating the Laplace of e to the t. I'd actually like you to hit pause and just try to do it real quick without looking at all this stuff that I have here. So go ahead, give it a shot, see if you can do it. It's very, very similar to what we just did, and I think you can totally do it on your own. If you want to just watch, here we go. Laplace of e to the 7t equals integral from 0 to infinity. The f of t is e to the 7t, so that goes here. E to the negative st dt. Well, that's the integral from 0 to infinity of, let's smash these two into the same exponent and then factor the t out, and we get e to the 7 minus s times t with respect to time. So let's do a quick integral just like this one. We divide by that coefficient of the t, 1 over 7 minus s times e to the negative, or e to the 7 minus, this is missing a parentheses and a t, so it should say e to the 7 minus s in parentheses times t. I'm going to evaluate that from t equals 0 to t equals infinity. And again, just like s had to be greater than a, we're going to have s greater than 7 for this thing in order to make it exponential decay. But what that's going to become is 0, because we're going to get exponential decay on this thing, minus 1 over 7 minus s. The 7 minus s comes from this term going to 1 and just grabbing this fraction. When I apply this negative in here, I get 1 over s minus 7. That's the Laplace of e to the 7t. So, last thing we're going to do is just, use logic and figure out what the Laplace of e to the at is. Well, we can just change this 7 here over to an a. And what I'm going to get for the Laplace of e to the at is that it's 1 over s minus a. And we always have to have this little restriction that s is bigger than a. So, and we're going to use that a ton, and I'll see you later. Peace.